Hello, welcome to my channel. So today let's look at today's Leetcode daily challenge question, which is also 698. Partition to k equals some subsets. Given an integer array nums and an integer k, return true if it is possible to divide this array into k non-empty subsets whose sums are all equal. So the example one, it given you this nums array and k equal to 4. So if we can, it's showing that it's possible to divide it into 4 subsets, 5, 1, 4, 2, 3, 2, 3. So it should return true. The second example, 1, 2, 3, 4, but k equal to 3. So no matter how you do it, it's impossible to divide this array to 3 subsets so that they have equal sums. So let's have a look at the constraint. So k is smaller than or equal to nums.length and also smaller than or equal to 16. So this is actually a hint that this question might be using the approach like a DFS, because we need to have it working at the 2 to the power of n. And also this one is the nums range. Nums I is between 1 and 10 to the power of 4. And the frequency of each element is in the range 1 and 4. Okay, so let's firstly analyze the problem. So let's take this array as an example, and so we can actually just do the brute force search. We can search all the like we firstly search 4, and if the sum is smaller than target, so actually we need a target. So we need to have a sum which is sum of nums from 0 to n minus 1. So yeah, and then we can get the target by divided by sum by k. Also, we need to check if the sum mod k is not 0, then which means it's impossible. Which means it's impossible to split the sub-array into k subsets so that they have equal sum. So now we have the target. So what we can do is we just do DFS search on the we just check each element, and then we check the next one. So I mean, if we add them together, the sum is larger than target, then we need to abort. But if it's smaller than target, then we can continue. So it's actually called DFS with the backtracking. So we also need to do the backtracking, and we need to have also visited array to record the num already used. So yeah, and the only thing is there is like a groups, right? Because we have k groups, so we need to have a group in the DFS function too. Yeah, so let's start coding, because this question is maybe a little easier when I explain when I'm also doing the coding. So yeah, firstly we can get the nums length, and then we can get the sum. I believe this one will get in the sum of all the elements in the nums. And now we need to get the target. Oh, so yeah, firstly we check if some mod k is not equal to 0. If it's not equal to 0, then we will return false. And now we can divide the sum by target. Right, so next is we can do the DFS. So so in the DFS we need to have a nums, and we can have a group called, firstly group starting with the 0, and then also the sum. I mean the current sum, which we already have in this group. And what else? Yeah, okay. Let's firstly define this DFS function. So nums group sum. Yeah, actually also we need to have a start. So start is we start from 0 in the. So the start is we are going to search from this point further on. So then yeah, we want to have those target, and I will define as a global variable, so then we can reference it in the also n, maybe n. Yeah, let me. Yeah, so now we can. So if the sum is larger than group, larger than target, right? Then it's we can actually return false, because it means impossible. So else, if sum is equal target, then we can return true. Then we can start searching. So when we search, we do the from start until end, and we search all the nums in this. So oh yeah, also actually sorry, sum if sum equal to target, it's not returning true. It's actually means this group is done. So actually we need to go to the next group. So what we need to do is group +1, and we need to reset the sum and the start, so that we will search again from the beginning of the array. So so if we also need to add this. So if the group is already k, yeah, we also need to we need to define this k as a global variable. So if it's already a k group, then we can return true, because it means we already have a. Oh, actually for this one, even we can even end the DFS at a k-1 group, because if the first k-1 group is with the target as sum, then it means the last group is also with the target as sum. So we don't need to search the last group. Okay, yeah. So now we need to do the Also another thing is we need to define the visited. So the visited will be like a n length Boolean array, and it's all false values initialized by default. So so we will check if this is already element is already visited, then we don't need to go this route. And then we can set it as true. And then we can do the DFS if the norms group and the sum plus norms I. Then the start we go to the I plus 1. So if this one is true, then we can return true. Then we need to change the df visited to false, which means it's called backtracking. So we can try other possible i's. So yeah, then if we didn't search, we after the entire search, we still cannot find then we return false. So yeah, this is the first code. So it's I mean there is still some optimization I'm going to add soon. So let's check if it's working. This first example is correct. Second example. False. Okay. So let's maybe submit this to see if it's it's accepted. Okay. Anyway, but let me add the optimizations. So firstly, one easy optimization is to sort the it's sort the norms, and then start from larger values. So sort the norms in descending order, and start from larger values, so that you actually can do the DFS, because the larger values it's more possible that it's not working. So if the target is for example, if target is like 5, but your array is so if you are do the DFS in this direction, which is ascending or like random, then you don't find this last two working actually until the later in the search. But if you change it to like sort in descending order, then you will like you will you will abort the search earlier. So yeah, okay, let's add that firstly. Arrays. Because in Java we cannot sort in descending order, we need to do the extra steps to swap. So yeah, to do the swap of from the beginning of with the beginning and the end of the array until in the midpoint, so that this one will be in the descending order. Yeah, so this one actually will make it a little faster. Then there is another optimization is when there is duplicates. For example, if we have a 1, 1, 1, then 2, and 3 or something, then we have more. So in this case, so when we do the search, DFS search, we actually, if we search the first element as 1, then we actually already search all the possibility to the right side. So, but if in the next one we start from 1 again, I mean, then actually what we are actually wasting the entire search to this direction, because all of them have been already searched. So to avoid this, we actually can add a condition that so if we only search this duplicate element if the previous one is not used. So so here we can add this if I is larger than 0 and nums I is same as nums I minus 1, and we have not visited I minus 1. So this is like we haven't used the previous number. Then we shouldn't use this number, because this number and the previous number is duplicate. So then we actually also do continue. Then this will make it like much faster if there are a lot of duplicates in the array. So yeah, also yeah, this get accepted again. And also let's talk a little about the time complexity. So the time complexity is this one is k times 2 to the power of 2 to the power of n. So because each element has a like either select or not select, so we will have 2 times 2 and until like n times. And also the space complexity is O of so this is the visiting array, so it's O over n. Either you can say the visiting size of visiting array and also the depth of recursion. Both are like a maximum n. So yeah, so this concludes today's session. So if you have any question, please comment in the video, and so if you like it, please subscribe or click like button. And so thank you for watching. See you next time.